Stupid window manager. Never happens on my computer at home. All right. There we go.
Well, this seems good enough.
Good enough, and we're exactly on time now.
Oh, perfect.
What happens if I change? No. Stupid.
Okay, so it's probably time to start. Okay, so welcome everyone. Welcome to the meeting of the 6LO working group. My name is Carlos Gomez. The other chair is Shweta Bandari, and the responsible AD is Eric Klein. There is some sort of audio issues, maybe. Yeah, now it's now it's better. Thank you. Okay, so thanks. As you can see, well, the chairs and the AD, we are all unfortunately remote this time, but then we have Michael Richardson as our delegate in the room. Thanks a lot, Michael, for helping. And also we have minute takers, Adnan, Dominique, and Michael, who have kindly volunteered as well. And also Michael will be our JavaScript today, so thanks a lot to all for helping and volunteering. Thank you. By the way, I think there was some additional part at the lower, like at the bottom of the screen, which is maybe not shown here. Yeah. Yeah, okay, thank you. Okay, so yeah, you can also find on the slide the pointer to the online agenda, which contains many links to useful resources, and also the link to HedgeDoc, which is the tool that we are going to use today for taking minutes. So recall that everyone can join and contribute to the process of taking minutes, so feel free to join and contribute to this collaborative process. Next, please. So, well, it's Wednesday already, so probably most or all of you already are quite aware of this. But anyway, well, this is the first IETF meeting that we have since the start of the COVID pandemic that has some in-person component. So for in-person participants, there are some tips to keep in mind. Please make sure that even if you are in the room physically, make sure that you sign into the session using Miteco, for example, by using the light client that you can find from the data tracker agenda. As in fact, we are going to use Miteco for managing the queue. So you need to use Miteco to join the queue. If you want to do so, there is a single unified queue. And also blue sheets are automatically generated from Miteco. So there are not like physical blue sheets. And for remote participants, the mechanics are like the same as in previous fully online meetings. Just make sure that your audio and video are off unless you are presenting. Next, please. So this is the notewell. This is a reminder of IETF policies on several important topics. So please make sure that you have read the notewell. Okay. Next, please. And this is the proposed agenda for today. So the first slot is the usual chair's introduction, which is currently in progress. Then there will be a presentation on the status update of IPv6 over PLC, given by Paolo. Then there will be a set of 4 presentations on the topic of ND, given by Pascal. These comprise the ND multicast address listener registration, then the ND Unicast Lookup, Also a presentation on a potential use of 6LoWPAN-ND outside the IoT domain. And finally, a presentation on the idea of a prefix registration, its applications, and relationship with Nfc 505. Next, please. Then there will be a presentation on the transmission of SHIP compressed packets over 15.4 given by myself. And that will be followed by a set of 2 presentations on the draft about native short address for LLN expansion. The first one will be a report on the last updates given by Luigi Iannone, and that will be followed by a demo given by Guangpeng Li. So this leads to a total of 100 minutes of scheduled time over the 2 hours of the session. So is there any comment, any objection to the agenda? Okay, so if there's no comment, let's proceed to the next slide, please. So this is the report about the working group documents. First of all, since the last IETF, we have a new RFC, that's 9159, about IPv6 mesh over BLE links. So congratulations to the authors, and many thanks to everyone who has contributed in the process by giving comments and reviews and so on. So then we have 2 documents that have been evaluated by the ISG. The first one is the IPv6 over NFC draft, which has been like a bit stuck for some time, although I understand that we have some news about potential next steps. So perhaps, Eric, if you may want to make comments on this, which could be like next steps.
Yes, thank you. I think at this point, basically, I need to double check with Lars real quick, and then just schedule it for to bring it back to a telechat on probably not the first telechat after this meeting, but late April or May. So if Lars wants to have some kind of a second last call, because it has been such a long time, we might need to do that, but I'm hoping that won't be the case. So I think I just need to update the Shepherd write-up to, I don't know, convey whatever people need to know to feel comfortable that everyone who needed to review the document at the L2, L3 layer interaction had access to the definition of the L2 layer. So, but that's unfortunately, yeah, it has not. I've not been able to make it a priority, but I'm catching up.
Okay, thank you for the update. So, yeah, it sounds like we have a plan for next steps. And yeah, then the next draft that has been also evaluated by the ISG is the draft about IPv6 over PLC. So actually, what you can see on the slide with the red and green colors is like not up to date anymore, because a few hours ago there were some updates here. So there were 2 remaining discussed ballots. However, both have been cleared in the last hours. So actually one of them, the one by Benjamin, still has a set of comments, and the authors may need to see whether they still may want to address them. Well, later we have a presentation slot for this draft, and perhaps we can further comment on this. Not sure if there's any comment at this moment.
I said to you in email, but I'll say it here. I think if the authors get a -11 that incorporates whatever it is they want to incorporate from Ben's comments, that'd be great, and I'd be happy to send it off to the RFC editor from there.
Okay, thank you. So the next document is the 6LO use cases draft. It was in AD evaluation. Also, there have been some recent updates in the last hours, and basically this is now in last call, IETF last call. There are a few comments by the AD, but our understanding is they can be addressed in future updates. So yeah, the document is now in IETF last call. And the last working group draft is the IPv6 ND multicast address listener registration. As you may recall, this was adopted right before the last IETF, and today we have a presentation on the last updates for this draft. So other than that, is there maybe any question, any comment? Okay, so if there's no questions or comments, let's proceed to the first presentation by Paolo on IPv6 over PLC.
You need your slides. Is this PLC? You're doing header compression? Is that it? Hello?
It's
Header compression?
the PLC.
PLC. PLC. And I think it's going to be correct.
Right.
There you go.
Good. So many thanks. So good morning. My name is Paolo Volpato. Let's say that, as you see, I'm not in the list of the authors of this draft. I'm presenting on behalf of the authors represented here. The reason why I'm here to talk about the transmission of IPv6 packets over PLC networks is that I had a talk with my colleagues at Huawei. They were not able to attend IETF113, so they asked me to act as a proxy on their behalf. So to update you about the status of the draft, and as explained by the chairs, I saw a couple of emails yesterday, I think, which to some extent obsoleted some of the content of this presentation. Anyway, we'll discuss that and we'll see what's the reaction. So next slide, please. Okay, so status you see here, basically the draft underwent the last call review, I think end of 2020. Telechat and ISG evaluation happened in summer 2021. After ISG evaluation, there were some discuss, and the authors were able to, let's say, review the draft and provide new versions just to address those discuss. By the way, the authors wishes to thank all the people who provided their reviews. And the result of the ISG evaluation got three discusses. One from Eric Winke, and I think that was, let's say, addressed by the most recent versions of the draft. Specifically, there was a major revision. It was 09, which addressed that comment. And then there were a couple of discussions that probably were partially addressed by the latest versions of the draft. One from Roman. Again, apparently it was okay after reviewing version 09, and that was completed in version 10. And the, let's say, the major point of discussion was the discuss raised by Benjamin, but as said, that happened before, let's say, IETF 113. There was a email sent yesterday, which, if I understand correctly, reconsidered the text provided by the authors. So the discuss was demoted to comment. So something has to be fixed still, but let's say probably the discuss is not applicable any longer. So that's for the status. Michael, if you can please move to the next slide. Okay, let's jump to the discuss provided by Benjamin. So the main point was about the use of the 2 bits, let's say, universal, local, and individual group bits in the first byte of the interface IED. So basically, the issue was that the original draft imposed those 2 bits to be set to 0, but that apparently was creating some issues, so that originated, let's say, the discussed by Benjamin. The authors reviewed that position, so they, let's say, lose the constraint, which was described in version 06, and basically provided 2 ways to deal with those 2 bits. So the first mode was to, let's say, use those 2 bits as originally intended, so maintain those bits to 0 when forming the interface IED, or the other mode, which was defined in the version 10 of the draft, was to leave to the operators, basically, to use freely those 2 bits without taking care of, let's say, how the specification set them originally. There are constraints, so the operator has to be aware that in doing so, it's very hard to move back from the 64 interface ID back to the short form of the same interface, of the same address. As said, that was the slide produced by the authors. The last comment by Benjamin, let's say, superseded the description provided in that slide. So next one, Michael, please. Then there was a comment received during the last call process, was about the interface ID entropy. Again, originally that was not included in the draft, but the latest versions, let's say, expanded a bit how this is, let's say, provided in the draft. Basically, the comment from Dave was it is needed to explain, to add, let's say, some components in the behavior of a PLC network on how to deal with the generation of the addresses, or add parameters such as the typical link time frame or lifetime. Basically, the authors introduced a new section, so they expanded section 8, which is about security. So they believe this issue has been fixed right now. Next slide, please. And finally, there was also discussed by Roman about, let's say, security. At the beginning, the draft was not including, let's say, all the possible mechanisms to deal with typical security issues. Let's say, talking with the authors, they explained me that actually they tried to expand the base text. So again, they touched section 8 of the draft. And also they pointed out that speaking of security is probably a much broader subject than just dealing with the typical security aspects in a PLC network, so just at layer 2. So their idea was to, let's say, expand the set of security mechanisms, not just dealing with layer 2, for example, payload encryption, or let's say cross authentication from a device to the PAN coordinator, but add other mechanisms at every possible layer of the stack, including the application layer. So basically, they introduced a comment that you see here in the slide: additional end-to-end security services that are probably active at every possible layer. And they explained me that this is also, let's say, related to the use you make of a PLC network and of the applications that actually the network is used for. So that we can move to the final slide. So again, when preparing the presentation, the authors clearly were not aware of the latest updates. So the mail sent by Benjamin yesterday, they wanted to ask further feedback to the chairs whether it's possible to move on, removing the discuss, and clearly having the possibility of developing probably a couple of new versions just to address the remaining comments before entering the publication queue. And I would say this is it. I hope I've been clear enough. In any case, if there are questions, you can ask me or clearly send to the mailing list. Thank you.
Questions from the floor? Go in the queue. Anyone remotely?
Well, perhaps just the point that Eric mentioned, that the authors may want to consider the comments in the last email from Benjamin, and then probably the document can proceed further.
That certainly works for me.
Oh, okay, so if there's no other comment, then we can proceed to the next presentations. Okay. Thank you, Paolo. And next is Pascal on the set of 4 presentations on topics and documents related with neighbor discovery.
So preloaded shared slides for, which one do you want first, Pascal? TUBEF, Unicast Lookup. That's what you would like? No.
Okay. Can you guys hear me?
Do you want multicast? Is that what you want first, those slides?
Multicast is fine, yes. Let's take them in order. But I just want to make sure that we have enough time for the last one. So I'll be quick on most of them, just to make sure we have enough time on prefix advertisement, basically, because that's where I would like to see discussions. So yes, multicast, please.
Multicast. Is this right?
I can pull them myself if you want, but just because now you have to give me the
slide control. You should have the slide control now.
I'm seeing it. Yes, very nice. Many thanks, Michael. So this first slide of introduction fits for pretty much the 4 presentation I'm going to do. So just giving some history on the work we've done in this group on what we call 6LoWPAN neighbor discovery, but we'll see that that's grown a lot beyond 6LoWPAN. But still, we are the source of this work. And today I will be talking about what we call Unicast Lookup, which is basically converging a backbone network for both traditional neighbor discovery and the stateful address configuration from 6LoWPAN-ND, and sharing a 6LBR basically to do Unicast lookups. So that's one draft we'll talk about today. And what I'm talking about now is the multicast registration, so extending basically 6LoWPAN-ND address registration options for Anycast and multicast. So since last IETF, we've bumped document version twice. One change was minor in terms of edition, but it was important in the field, is there was no discussion at all about all nodes multicast, link scope multicast group. And effectively in IPv6, every host is implicitly in that group. So just added some text to say, well, this is true too. So if the 6LR sees any traffic from a host or registration from a host, so it has the SSLAO of that host. So basically, implicitly, that host is a target if there is an FFO2 column 1 packet. We have refined how this address protection RFC 8928 is leveraged for registering address. So we have more text on that. And that's another draft I'll be talking about today, but we are proposing a method to register IPv6 addresses to BES, so to BGP basically in the EVPN environment. So using 8505 as the registration protocol to be redistributed into EVPN. And basically, we would like to be able to register not only unicast, but also anycast and multicast. So there's some text about that. Since IETF 112, I'm sorry, during IETF 112, we've discussed anycast and backward compatibility. So that was published right during the IETF session, and maybe people have not seen it. So I just want to insist that that was done. And that was we needed a flag field in the header, and we did not have one. So we repurposed the status of the request. The status is only valid in the response. And so we repurposed the status field, which was basically reserved on the header message to carry the flags. And now we can carry that the header is for an anycast or a multicast address. So these are the recent changes since 01. Any question at this stage? Just interrupt me.
Put your hand up in the queue.
So basically the question now for this group is, are we missing items? Is there some more work we want to do here? Because at some point we need to transfer the token to role. I'm not saying we necessarily ask or what, but role is not yet really observing this document. But it's the main change that we do here is not really the A and M bits in the registration to say anycast or multicast. What's really important is how we change basically the Ripple unaware leaf work, which is RFC 9010, to expose those anycast and multicast addresses in Ripple. And there is the introduction of a new mode of operation, MOB 5, for non-storing mode multicast. So for all those changes, we need role to take a good attention on this document. So basically what I would like to get from this group is a green light. Say, hey, we are reasonably happy with this. We can still work on it, but we are reasonably happy. So we'd like to pass the token to role. So if you guys could comment on the list and basically express comments, like see it as an early work group last call from this group if you like, but it's mostly passing the token on. And this afternoon we'll be talking about it at role as well.
Yes, so thank you, Pascal. So yeah, there was some more discussion initially, and it seems like now the document is getting stable. Perhaps it would be good if anyone would like to volunteer to review the draft at this stage. Not sure if anyone attending at the moment, or maybe we can ask later on the mailing list.
It would be great, yes.
Yeah.
And also, if you remember, this work was steered actually by the WISEN Association. I mean, the WISEN is a group that standardizes technology for the smart grid based on Ripple and 6LoWPAN. And I also asked them to publish a review on this list. Okay, and that's it for this one. Michael, do you want me to pull the next one? I think I can.
Sorry, there is a question on the chat by Karsten. Has anyone looked at how these...
Excuse my ignorance. Has anyone looked how this works with the multicast registration that is part of the constraint cast document?
Actually, no. And that would be a good thing to discuss, actually. I remember very well the constraint cast. It's just that, well, that it existed and some, but no, I've not dug into that. Do you want to? We can work offline on that if you're interested.
Yeah, we probably should.
Yeah, well, welcome. So Unicast Lookup. So then again, same family, same introduction. So basically with RFC 8929, we've got what we call the backbone router, which is a proxy ND function. So you can register on the LLN on the 6LoWPAN network to addresses, and the 6BBR will do ND proxy for you on the backbone. And that applies to classical 15.4, that applies to .11, that applies to many things. But at the moment, there was no real work on what happens if we want to use the registration on the backbone side as well. Actually, I tested it, it works fine. But Yeah, we probably need to standardize it. And the most important thing or interesting thing is, if you want to move the registration to the backbone, probably you want to move the 6LBR to the backbone. Now, if you have a 6LBR on the backbone, that kind of tells you that you can use it not only as a DAD database, but also for lookup. And so what so you avoid the broadcast or the bump, as they call it, broadcast unknown and multicast flows on the backbone, if you can first ask the 6LBR, oh, by the way, do you have a registration for this address? In which case I won't do the classical lookup or that. So that's basically what this document says. It proposes a way to place the 6LBR on the backbone. And remember, the 6LBR is very, very abstract. I'll come back to that on the VPN discussion. But the abstract 6LBR is now reachable over the backbone or even far, far away on the internet because it's a global IP address. And we can effectively pull its database information not only for, oh, is this address duplicate, but also what's the address resolution. So what we really do in this draft is we extend the DARDAC exchange so we can provide SLA options. And so this is still a personal submission. It's been very, very stable. So we are in this situation of adopt or drop. So do we care about publishing this work, which basically says now you can have 6LoWPAN devices on the backbone, sleeping, etc., because now you can benefit from the proxy for sleep proxy, etc. Or do we want to keep 6LoWPAN at the edge on the other side of the backbone and outside of the backbone? Personally, you know my side. I want basically to converge the registration on the backbone, but any feedback? Basically, I would like to call for adoption. I mean, it won't move far beyond this if we don't adopt it. So it's really adopt or forget.
Yeah, so Karsten is in the queue.
Yeah, so I was wondering, given that we now do 6LoWPAN signaling on the backbone side, is that useful on the backbone for other nodes as well?
Yeah, I mean, if everybody, basically, the more devices contribute to the registration on the backbone, the less bump traffic broadcast unknown multicast you will get on the backbone. Because the draft will be more and more useful because the nodes will be able to look up through the 6LBR and never again do a multicast.
So this is essentially a soft entry to efficient ND.
It is, yeah. You can see it this way.
Yeah,
Yes,
okay.
it's making ND more efficient.
Look at the draft again.
All this work is the evolution of efficient ND. I mean, or it's all efficient ND was always completely linked to this.
Okay.
But we did not. I don't think we really discussed of placing the 6LBR on the backbone and doing Unicast lookup. Now we do. But it was the obvious continuation of efficient ND, if you like.
Yeah. So we certainly can do this work in the working group. I just wanted to raise the question now. It's not against adoption at all.
Yeah, and we actually started this document at 6man. And 6man, for anything related to 6LoWPAN ND, I mean, doesn't really care. And so I presented it once or twice, raised a few eyebrows, and that was it. Pretty much like efficient ND. I mean, you've seen the lack of interest to progress this work at 6man. 6man is more maintenance, as I see it. And so look at the Service 6, right? They do the work in spring, and sometimes when they have something, then they just get 6man to validate that it's okay or change a little bit. But here, same thing. We've done this work, and 6man will basically just say it's okay or not. But it won't advance in 6man. They're not doing that sort of thing. I tried. It's been there. Okay. So yes, I mean, I would like to see a discussion on adoption on the mailing list. So the introduction to the next discussion is, remember the 6LBR, you might see it as a server, but in fact, it's really, really abstract. If you look at 892.9, which is the backbone router, the global 6LBR is effectively the collection of all the ND information on all the 6 BBRs, because all the backbone routers, they have a partial view of the 6 LBR for their own local LLM. But the real 6 LBR is the aggregation of all those views. And the way this real 6 LBR, distributed to 6 BBR, I'm sorry, is read is by doing classical ND over the backbone or over the proxy function. So it's not a centralized box at all. It's really the collection of all the backbone routers together being read through ND. That's what the backbone router does. Now, can we move to the next slide where the EVPN one? Let me show you another way of deploying a 6 LBR. And in this case, 6 LBR would be literally BGP, the whole BGP network that serves EVPN.
Is that the right slide?
Thank you, Michael. Yes, I see them. So please bear with me because this slideware was not done for this audience. And I'm just telling you that I presented it to them. The classical EVPN world and the classical cloud world is really, really IPv4. They understand IETF, people understand IPv6, but not in the same depth as people doing IoT, for instance, right? And so sometimes, and really in enterprise networks, they mostly don't let Slack at all, and they work with the HTTP with V6 just the same way they work with V4. So it's kind of easy to forget that there is more to IPv6 than the HTTP. For the best, for the better and the worse, right? So basically, I was with this slide, I was making the point that as long as you use the HTTP, you've got this round trip between the client and the server that you can observe on the way. So you can snoop the HTTP reliably. You can expect it, one address per host or per interface. You know it's going to come. Actually, in our access points for instance machine, the access point association is up when we have seen the DHCP packet and when we know which IPv4 address this host has. And effectively, that's completely different from the IPv6 world, where you will have multiple IPv6 addresses that will come and go. So as long as it's the HTTP, I mean, you might be tempted to believe that V4 and V6 are the same, but not. And for EVPN in particular, but also for wireless, the ASL is the SL in Slack. It's the stateless piece. Because the way Slack is done cannot be deterministically observed. It's just based on some broadcast DAD and potentially some lookup later. You don't know for sure when a host forms an address. When it stops using it, there is absolutely no signal that this host will stop using this address. And so you end up with addresses that you don't know exist and addresses that are no more used, but you still maintain a state in the network for them. Slack was not at all defined for maintaining state in the network. It was meant for maintaining caches in the network. It's very, very different because EVPN needs a deterministic state that can be injected in BGP. So using Slack addresses and redistributing them, snooping them and redistributing them in EVPN leads to broadcast unknown and multicast traffic, which is one thing they want to avoid. So this next slide basically explains the kind of problems we have with Slack when we want to interwork with EVPN. It summarizes what I just said if you want to maintain the slide, but I don't have so much time. So that was true with Slack until we made IPv6 ND stateful, and that's 8545, 6775, 8545, and 929. I mean, the whole series that I've shown on the first slide. With this protocol, we effectively synchronize the state about the address between the host and the network. Now we have a deterministic state that we can redistribute into routing. And effectively, 8545 carries address control semantics, which help this redistribution. In particular, we negotiate the lifetime, and that's inherited from 6775. And we have special signaling to say, please redistribute my address. So the router can inject the address in a proxy that's at 929, in REPL, that's 901010, that's 9010, and in this case with EVPN. And here in the cake, we have a quite simple address protection mechanism, which with 8928. So we can do Savvy and all those games. We can bar traffic which is not sourced by the user who effectively registered that address on the first hop switch or first hop router. So basically, it is the draft that I presented to Bess, and I'm trying to get it adapted, is explain how you will redistribute RFC 8505 and 8928 in EVPN. And if you look at it, that effectively makes the BGP tables that are synchronized in every node V6LBR. Because EVPN basically advertises routes type 2, which really are combination of IP and MAC, and type 5, which would be the IP. And what we do is we extend the support that was already there for basically ND, IPv6 ND. There was a beginning IPv6 ND in there. There is no RFC for that, and so we extend that signaling, and we also effectively have two different fields that we update because we need a number of flags, and we need to expose the lifetime, we need to expose the rover. So how we do that is explained in this document. The bottom line is now we can provide a secured address, and that's why you have secure in the titles, because 8928 and 8928 information is effectively injected in BGP. And so BGP can block a host which would like to steal an address to impersonate over EVPN. So benefits are really address protection and deterministic state. And that's illustrated here. And I won't spend more time on those slides. So I will
There's
any question?
A question. Well, Eric is in the queue. So Eric, if
please.
you want.
Eric
Good to see you.
Hello. So when people do this with IPv4, presumably they can know when addresses are no longer being used, the unregistered part, right? By setting a lease at an hour or 24 hours or whatever.
Yeah.
I don't
they
remember
know
how much.
It's gone.
Yeah. Well,
yeah.
If something moves and the lease is 24 hours, they won't know that it disappeared for 24 hours. But
for 24 hours. But after that, they do.
But do we have in the set of things we have with the registration? I don't remember. Do we have enough sort of resolution there in terms of things disappearing, being unregistered, in terms of timers, or?
We have a lifetime in the registration, and what's neat with 6775 is the host proposes a lifetime, and the router confirms it or modifies it, like reduces it. So we can effectively we register with a lifetime. Yes, we do. Now the resolution is whatever we can signal. I don't remember exactly. It's 2 bytes. I don't remember the unit. It's probably seconds.
Yeah. Okay. So yeah, that's good, because otherwise people will later discover that, hey, we need to unregister better, but we have what we need. So
well, you have both, right? You can normally the draft should, if you stop using an address, there is a should, something like register it with a lifetime 0, which means unregister. Now, if you don't, then the lifetime will time out. The other thing is there is text which says that your registration should map your intention with this address. Like if you have the intention to use it long term, use a long lifetime. If you use it like just a very temporary address, use a short lifetime. Now it's under the appreciation of the stack to decide what kind of lifetime it will ask. So we have a lot more control actually. And we have the rover, which will allow to ensure that it's the rightful owner, because a DUID in the HTTP can be impersonated. Okay, and last slide, please, and that's the one I wanted to insist the most. How much time do I have left, please, chairs?
In theory, according to the agenda, there would be like 16 minutes, although we also have additional time since we have like 20 minutes of flex time for the whole session.
Okay, that's neat. Okay, so same first slide, the big family that this group has developed. So I've been working on cloud usage of what we did in this group. Don't be too surprised with the VPN. But the next thing that happens in cloud environment, and you will realize it happens in IoT environments as well, is at some point you want to give this device not just an address, but you want to give it a prefix. And the kind of usage is in the cloud. It's you've got a virtual router in your host system, in your server, like something like Calico, and basically you want the DevOps to be able to manage not only addresses but prefixes. And so the DevOps would configure prefixes on their systems, and what you want is the system to advertise that to whatever routing you have in the cloud in a fashion that's completely agnostic to the routing in the cloud. So you can do Rift, you can do BGP, you can do whatever. And for addresses, H545 is fine for that purpose because it's indeed completely agnostic to the routing protocol in which you redistribute. But we do that only for addresses. We don't do that for prefixes. Now, redistributing is not something new at all. We do it with a REPL, with the REPL and nowhere work. In this case, the 6LN registers an address with the R bit set, and the REPL first up REPL aware router will effectively react to the R flag and inject in REPL. The same flag is used in 892.8.29, I'm sorry, by the backbone router to decide whether or not to proxy. And that flag is also leveraged in the best work. So what we are looking at is not something new, redistribution, but redistributing prefixes as opposed to host. And this is a quick view on how that happens. So this is the traditional REPL non-storing mode. So each node will have an address in the same prefix. And basically, the node send a non-storing mode DAO like this red packet to the root, and the root can construct a source route path back, which is the AC via AB, which is connected. Now, with the REPL and aware leaf, what you do is you've got this host, which will see an array from router C, autoconf an address A column L for low power node, and basically it will be the node C that will advertise L as a non-storing DAO on behalf. So what happens between A column L and A column C is pure H545. L is completely agnostic and aware that it's REPL, and the address is injected in the routing, and the node can be served. So the question again is, yeah, we can do that for addresses, but what about prefixes? I mean, does that make any sense? And actually, there are a number of use cases where it does make sense, and the broad category is a stub network. It's a network that is either inside the node, what we call a networking node, or a recursive networking, where there is a node is a network for the next level of recursion, or a private network, a virtual network that would be managed, for instance, by Kubernetes or something. You could also have a NAT function and a private realm. That's really what you would do in Kubernetes, but you can also connect through REPL or any network, a smaller network of private IoT devices without really knowing what kind of routing takes place there. What you want is just be able to signal through the same simple registration we have with H545. Hey, this device, which does something different from REPL, effectively owns this private realm or something. So yes, as long as it's a stub, as long as it's reachable only via these devices or those two devices which work together, it makes perfect sense to expose not only a host address, but a prefix. In REPL, and that was there forever. I mean, exposing a prefix on REPL, which is exemplified here, this is a typical structure that REPL could build. So each node ABCD get a prefix ABCD, and if C connects to B, then it will form a prefix, an address of B's prefix. And then you can expose the same sequence of source route information again, and it's going to work fine. Because in REPL, what B will expose is B column /64. as opposed to a host, it will just expose a prefix, and REPL is built for that. So each node has a prefix, each node forms addresses from its parents, and you're all set. That works for storing mode, non-storing mode, everything. Now, if we wanted to do the exact same thing for REPL unaware routers, no, we don't have it. We don't have a way for node L to effectively say, oh, everything under L column constant 64 is mine. L would have to talk REPL. And if it's CVPN, L would have to talk EVPN. The very cool thing about 8505 is completely agnostic to what routing protocol L is doing or what environment it has, like if it's inside the server, versus what goes in the REPL network. So what we're after here is really a simple way for a stub to say, hey, I'm a stub, please give me the packets, but I don't know what your routing protocol is. And I think it was yesterday at 6man, there was a question, a use case that was quite interesting, where there was a unique local prefix which was owned by a router which was somewhere on the home network. If that guy had used this registration to talk to the home gateway, problem gone. Packets would reach the home gateway. The home gateway would find the registration for the ULA prefix route. End of the story. But we don't have this simple ND extension. And I remember Jen at some point talked to the group and say, hey, we are not listening to arrays. This ULA router would have advertised arrays, but then the home gateway does not listen to arrays, so we lose the information. That's why we have the prompt. Well, in this case, we use RS effectively to register. So it's just like NS for host. Naturally, would migrate it to RS, I guess, but that's the group to decide. In this case, effectively, the home gateway would listen to the RS with the address registration option or something, prefix registration option. And it will effectively know in a fashion which is completely independent of what routing takes place outside the home network or even within the home network. It will know that there is this router which owns that stub and which is connected. And effectively, it still works if the stub itself is a different subnet on the same multi-subnet link. This is very traditional shared link, existed since the early times of IPv4, where you have a same wire, if you like, where multiple subnets are deployed. It just happens that the home gateway would pass the packet to the router which did the registration, which would then inject on the link. Whether the link is the same as the home link or a different link doesn't matter. It works. It would work anyway. So yes, we would register prefixes, but when we register addresses, we have this thing which is quite useful, which is that, right? We want to ensure that a given prefix is a given address is not a duplicate. So we would need to do that, right? Yeah, we would effectively, mostly if we want the DevOps to configure prefixes on their devices without asking too much, just picking something in a larger aggregation. Yeah, you have the risk of duplicate. Is it free duplicate? No, it's not. I mean, it could be an exact duplicate for a prefix, but it could also be something which deals with an aggregation, like I'm stealing a prefix from an aggregation that is already registered by somebody else. So basically, yes, we would need to do that again, but we would need to consider not just exact match, but also aggregation. Like some prefixes could be exposed as being prefixes from which you can steal a sub-prefix. And some of those would basically not be proposed that way. So if you register, for instance, a prefix within the prefix and you have the right to do that, then you get it. If somebody wants to register the same, you won't be able to do it because you own it, unless you say Unicast something. But then if somebody wants to dig into your own prefix, if you did not allow for that, it will be rejected as well, right? So you have to consider aggregation as part of the DAD. But otherwise, yes, the very cool thing, if you can do auto allocation, you can do prefix autoconf with this. And then the traditional DAD method, extended to understand aggregation, would do the trick for us. So the proposed way, I've not written the draft yet. I just want to, I don't want to waste too much time unless people are interested. But for me, the obvious way is to do with RS what we did with NS and do a stub registration option. I insist on the fact it's stub, right? Because with that, we don't have, it's not a routing protocol, it's still ND. we are just advertising reachability, but we are not addressing cost, etc. We are not participating to the routing protocol. Very important distinction. And so we just say, hey, I have this prefix, and I want you yes, bit is set, to inject it in your own routing, and give me the packets back, please. And since it's a stub, it won't be a loop, it won't be anything. So that's why I suggested this stub registration option name. And then in this example, I have a cloud fabric, and I have this server down below attached to two leaves, L1 and L2. And it would basically send the RS to L1 and L2 saying, I'm registering this prefix. And then L1 and L2, the two leaves, could effectively inject it in BGP, EVPN, or Rift, or whatever else you want to run there. And the same obviously would work for repo.
Sorry, Pascal. So there is Greta and Michael waiting in the queue.
Oh, I'm sorry. I had scrolled down and I did not see the queue. Oh, now I scrolled up and I see you both. Sorry. It's my fault. It's just the scrolling thing. I mean, the queue does not show when you scroll down. Something for Mitico guys, if you could make sure that the queue shows outside of the list of participants. Is always at the top. That would be very useful. I just made that mistake. Okay, go ahead, please.
No problem,
So
Pascal.
Shweta, you're first.
Hey, Pascal, could you reiterate or summarize on the use case how this fits into the 6LO charter? I'm not very sure if Kubernetes, Calico, all this is applicable in the constrained environment.
We are so abstract. It fits as long as you have, for instance, if you have an IoT network instead of this server down there, it's just a plain existing IoT network, which is V4, for instance. I mean, there are a lot of them, or not IP at all, but you want to map each device to an IP address, just map like a NAT function that would map a MAC to an IP. Then you can expose effectively every device on that /P to the repo network. So if you see, that's why I picked on my example before on repo. Effectively, repo has the model already for LLMs, where each of the routers owns a prefix. It's there. I mean, it's always been there. So this can happen if the router C is effectively the gateway to an IPv6 network, which has the prefix B. But it could also be something else, and that we could not necessarily. How can I say this? Yeah, it could be anything. It's there. What does not exist is the capability to connect a gateway which does not speak repo. So yeah, I'm sorry for that. So the thing that exists today is this. The thing that does not exist today is this, where you take this IoT gateway, which has a number of devices below it, and which wants to map the devices in that group of devices to an IP subnet that can be injected in repo. And you don't want to have to. Sorry?
Or another routing protocol.
Yeah, it's completely abstract now. We basically say what's good with 6LoWPAN, what's good with ND. It's completely abstract, the routing protocols. You can advertise a prefix to say, hey, reachable, but you cannot give a cost or something like that. You're not a routing protocol. But at least if you have a stub, you should be able to announce it. And like Michael said, regardless of what routing takes place over. So I take the example of a cloud, or I take the example of repo. It really doesn't matter. We're completely agnostic. Actually, that's the value of doing it in ND. But in this case,
so,
yes, if you, yeah.
So this enables 6LRs and LBRs to advertise prefixes that will be in turn delegated or mapped to the constraint nodes.
Yeah, the constraint node gateway. Yeah, there is a gateway which serves constraint nodes, and we want to be completely agnostic of what it does. Maybe it does not even do IP, but we want to be able to talk to every device in there. So we want to give them each an IP address. And the simple way for that is that the gateway has an IP address for all of them, whether it's really the prefix that is distributed to the devices, or it's just mapping some NATs that is done at the gateway. But at least we want to be able through the gateway to talk to every Modbus device. And for that, we want the gateway to own a prefix. Now, either the gateway speaks repo, Or we extended 545 to say, hey, the gateway speaks 6LoWPAN-ND, but gents, we can expose the stub as opposed to just the untras. So what I really want to do is what we did here and made sense for a single device. I want to make sure we can also do it here when the device is actually a gateway to more devices.
Thank you, Pascal.
Yes, Michael?
So I wanted to say that Anima's ACP is already injecting prefixes into Ripple, into the ACP Ripple, but that this actually would be very interesting because it would mean that in, for instance, the NOC, which might run the ACP as a native network rather than a overlay, that would actually permit us to have some structure in the NOC. I think that would be very valuable. I think that would be so I think this is a kind of a useful, very useful thing to Anima, this extended prefix allocation. And I just wanted to say, actually, in response to Shweta's question to you about charter, it might very well be that this work does not belong in 6LO, but this is essentially, I think that we need to be aware of this because this is essentially an evolution of 8505, which is our document in other working groups, right? So I think that's a relevance to this working group, is that we wish to have our children go forth and be fruitful, right?
Yeah, I agree with that, but then we don't have a working group to push that work on.
Well, I don't
right?
know. It just, if it's not 6LO, I don't know where it is, but the point is that it is
Exactly.
based on our document. So
It is.
think
I
that's one
completely
of the
agree
ways
with you, Michael. But I hope more than just interest. I really hope that we develop that here because that's where we have the skills for it. So yes, my argument is effectively this L node could be an IoT gateway. We have many cases of IoT gateway in industrial, and where you have all sorts of industrial protocols having their own addressing scheme. And basically what we would like is to be able to have the gateway map every address in its network to IPv6, and then inject that in the routing regardless of what protocol runs in the routing. So in that case, it's pure LLM, it's pure IoT. Now, obviously it's not what I'm saying is just not limited to IoT. I mean, it would have solved the problem that we saw yesterday at 6man, just by a snap of the fingers. And it's what came to Jen naturally say, oh, too bad the array is not read by the home gateway. Well, no, the array no, but the rest yes.
Okay, there's also a question on the chat by Karsten. I think it was related with the last slide that you were presenting before the question.
Yeah, I'm like the student who at the end of a talk that explains how to build computers out of transistors asks, what is a transistor? The prefix B is related in what way to the prefix A?
Okay, so it's not that picture. I'm sorry, let me bring back the picture. So in this case, there is absolutely no relation between A and B. It could be two different cars served by two different service providers. It's just, and then you build a many of cars, and that still works. So no, there is no relation. That can be or that can be not, right? You don't really care. It's just that when the car, say A is a car, and you have an IoT network inside that car, or the units that you get in the car, that is served through Wi-Fi, then the car as basically is exposing A column /64, right? And if you want to build a network of cars, then basically you expose that in arrays in the clear, and then car B can join that. And effectively, if you do that, you want some privacy both in A as a prefix. You want to kind of take it from a temporary ULA just for visitors. And B should use a suffix B in this case for A column B, which also would be anonymous. But the bottom line is you can effectively have B connect to A by forming an address based on A arrays. And recursively, you do that, and you do report between them. And guess what? You form a network that reaches the outside of a parking lot or connects them and A together. Actually, this is how we experimented with Ripple like 20 years ago, before anything, the role group was proposed or anything. We are doing that with cars. We are building exactly what you see here. And this drawing is kind of old. It was tested by NASA, by the way, at Glen Center. They were streaming video across cars to us as they were driving. 2002. Okay, so nothing much more. I just this is a slide I made for the EVPN people, but basically you would see how it could happen in an EVPN case. But yeah, then again, it's completely agnostic to the routing protocol that you would run. If we get a little bit gorier on what we would like, so the main change is to advertise stub prefixes as opposed to hosts. You can effectively advertise /96 if you want to expose a private IPv4 domain like you would do for Kubernetes. We could, as we work on this draft, add more information about policies and ACLs. So if you want to have access controls, etc., they have the right to do this, or I claim the right to do that for this prefix, then that could be signaled. The other thing that could be signaled is metrics to influence not routing. Then again, we don't do routing, but to influence load balancing. Like if you have a Ripple network or an EVPN network, FAT3 class fabric, there is a lot of load balancing taking place. It's not routing, it's just load balancing. And the question is, if I have multiple of those gateways serving the same network, it might be that you want the weight to be unevenly distributed between those guys. And so you could effectively advertise information about that. And then all sorts of things which could be placed for v4, like tenant ID, VRF, etc. I need to say, because this is an IETF meeting, blah, there is some IPR on all these games, right? So we have found some IPR on explaining how those different things could happen. And so basically, that's what I'm looking for is a discussion on this list. And I had the point by Shweta is, does this fit Charter? I think it does. It's certainly not limited to IoT. But before I start going into a draft, as you know, the draft 0 is always a lot of work if you want to do it right. I wanted to expose the ideas to the group and kind of get a go, no go feedback. Luigi?
Yes, I'm here. You hear me? So actually, if you can go back one slide, just one slide. So I think that the work is interesting. I just wanted to make a comment on the third main bullet, adding metrics to influence load balancing. Yesterday, there was this CANBOF, compute and networking. I think it was the acronym. Anyway, they work on a similar problem in a certain way, because they use compute metrics and network-related metrics, which is like worker capacities, access bandwidth.
Yeah, exactly. That could be exactly very, very good. That's exactly what the sort of thing we had in mind. Yeah, if basically, for instance, if you have Kubernetes again, right, and you can decide how many pods you have on different servers, you could basically load balance on the number of pods.
Yeah. I think there is some overlap. This may be a different solution. I don't know. Maybe you get in contact
I did
with
not
them,
know.
And there is some connection there. Otherwise, the work is interesting. That's it.
Thank you, Luigi. Carsten?
Yeah, I need to continue asking my question because somehow I got disconnected here. I still don't understand the relationship between A and B. So is B a subprefix of A?
No. I'm sorry. Oh, you were disconnected. Yeah, so you did not share my response. They're completely unrelated. They can be related, but there is no requirement at all that there is any relation between A and
What
B.
is the job of the LBR then? The LBR suddenly gets additional networks it's responsible for?
Okay, so you're talking about the 6LBR, right? SABR, the 6LBR, the registry? The registry is only useful if you do the function that is equivalent to that, right? If you want to auto-configure the addresses. So basically, say those are cars and they are service providers, and the service providers did give them a /64, which is A, B, or C. Now those cars end up in the same parking lot, and they want to form a MANA of sort with REPL. Basically, they would advertise an address. And they can advertise this GUI unique prefix they have, or they can autoconf a ULA prefix. If you really want to ensure that the ULA prefix that is autoconfed for anonymity purpose, just for forming this network, is really unique inside that parking lot, then you would have a 6LBR. If you're using global addresses, you would not need the 6LBR because every prefix ABC is unique. It's being just given by each service provider, and then yes, there is no relationship at all between A, B, and C.
Okay, then I really don't understand why A and B are on the same diagram, because they seem to have no relationship at all.
No, there's just two cars parked next to one another, or
Yeah,
two
but
devices.
your picture has things on it that have prefix A and things that have prefix B.
Yeah,
And
node B as prefix B, owns prefix B as a router, and node C autoconfs an address from B. We're using C as an IID. It's just so the prefix B is owned by router B. Yeah, so he's the router which has that prefix. C is a host attached to B, forming address B column C.
so what do the hosts that are in A have to do with B?
What are the hosts? I'm sorry, I missed some words.
The hosts that are in A, what do they have to do with B? B as a prefix.
The only one that has anything to do is node B itself, because is as a host on one antenna, if you like, is a host to A, and then as a router is the router for prefix B. So the interconnection between A and B is the fact that there is a router B which acted as a host on one leg to form an address from A, and on the other leg acts as a router for exposing B. He creates that link, that connection, if you like, during the time where it's reachable from A. And when B goes away from A, address A column B will go away. It will have to deprecate
So
it.
the nodes in A cannot address any nodes in B.
Without REPL, they can't. But once you run REPL and say A becomes the root, just because from the diagram it looks like obvious, then if a node in A pings an address like B column C through REPL, it will know it's there. So that's when you need the routing, right? I mean, the routing, REPL does exactly what I've shown on the slides. Basically, REPL builds this,
Okay.
right? A is the root, blah, blah. Here is the routing tables in every node. So for instance, in node B, which is in the middle, prefix B appears as connected, right? And it's actually owned. And prefix A is connected, but as a host. And then B has a default route via A, which is a root. And C and D, they basically autoconf an address from B. So they see B as connected. They see their own prefix as connected, default route via B, right? That's REPL for you. So it's just REPL used in some MANA form, if you like.
Okay,
And that works.
I'm used to using REPL in stub networks, so this is now has transit networks. So
it's not transit if you don't connect to anything, right? If, for instance, A might be connected to nothing. It's just the election the natural election which will have made him being the root. Like,
Yeah,
you know,
I
it
think
just
that's
starts
heavily
both sense.
unlikely case.
Well,
So
it's not how it's
normally
used today,
we will
right?
be on the
It's
internet.
just that it works. If you ideally you connect A to the internet, it makes a lot of more sense. Yeah. So you
Then
connect A to the internet.
becomes the transit network to B.
Oh. So if you say what you call the ABR can be A, works fine.
Yeah. Okay, I'm looking forward to your draft because to me this makes absolutely no sense.
This would not be in the draft. I mean, this has been in my Ripple course for 15 years, but it's not in the draft because the draft would more would probably discuss that slide which would probably incur having the other one. Yeah, if you like. I mean, to explain as background that I don't want to overload the document either with Ripple consideration when it's really talking about MD. So yeah, I mean, I would be happy to discuss about those slides anywhere in any forum you want, including this mailing list. But saying that I will write that in the draft, I don't expect to.
Yeah,
This is
it's
pure
not
Ripple
interesting.
deployment.
It's not so interesting how Ripple does this. It's more interesting what capabilities and responsibilities you assign to the various nodes in the network here.
Oh yeah, cool. So now we are back to this case. And it's basically saying there is a routed network where C is a 6LO, if you like. And then there is this gateway which needs a prefix and doesn't speak Ripple. So it's a Ripple unaware router. And we call that an external destination in RFC 8008. 9008. So use of Ripple info. This is an external destination. So how do you get knowledge of external destinations that are not hosts? And right now there was nothing. So now we have a protocol.
Okay, so sorry to interrupt. There's also Guangpeng in the queue, so perhaps we may have like time for an extra question by Guangpeng, and hopefully you can continue the discussion, for example, on the mailing list. And now, yeah, just time for a quick question from Guangpeng.
Okay, thank you. Hi, Pascal. Does this mean the root is gathered by the root node, and then for the communication, every packet will carry the root message in the encapsulation?
Oh, if you're using, in this case, it's using non-storing mode, and so RFC 9008 applies. And yes, it does mean that C will encapsulate the packet to the root. I think, if I remember well. we had a lot of trouble writing 9008, but this is whether it's really a Ripple unaware leaf or it's any external destination doesn't make a difference. And my memory is effectively C will encapsulate to the root, and then the root will either encapsulate if it's another rule destination, or if it's not a rule destination, then he might. Well, if it's non-storing mode, it will encapsulate. So yes.
Okay, understand. Okay, thank you.
But yes, always, go back to 9008. It was so hard. We always miss things when we do it by memory. But same as a rule. I mean, whether it's an external host or external prefix doesn't make any difference.
Okay, so thanks for the presentation and discussion. So it appears that, it may be good to confirm further on the mailing list that there is interest in this work. Also, it was good to clarify relationship with the charter. So it appears this whole work area can apply in IoT networks, but also it's not limited to that. So yeah, it was also useful to clarify those aspects as well. Okay, so then thank you, and I guess we can proceed to the next presentation. Actually, I think it's me this time. Yeah, I'm seeing the broken format.
Do you want to display your own slides then?
So yeah, share preloaded slides. I'm still seeing like
Yeah,
a
so-
broken
so
format.
You'll have to share your PDF.
You have to share your screen.
My screen, okay.
Yeah.
So
And now we know that whatever PDF process you used results in broken slides. So we have a test case. Yeah.
okay, so I'm starting to share.
Don't share your whole screen.
Okay, can you see the screen? Sorry, the slide correctly?
Yeah, it looks great.
Okay, thank you. Okay, so Carlos Gomez again. I'm going to present the last update of the draft entitled Transmission of SHIC compressed packets over IEEE 802.15.4 networks. My co-author is Ana Minaburo from Aclio. And let's first take a look at the motivation for this draft. So as the working group knows well, RFC 6282 has been the basis for header compression in 6LoWPAN and also in 6Lo. It was designed for 15.4 as the target technology to support IPv6 on, and it has been adapted or reused for several relatively similar IoT technologies several times, such as the ones that we are handling in 6Lo. And with this RFC, it is possible to compress an IPv6 UDP header, typically 48 bytes, down to a size of 7 bytes in the best case with global addresses. But then we also have the recent publication of RFC 8724, also known as SHIC, which is a product of the LP1 working group. SHIC defines adaptation layer functionality, comprising header compression and fragmentation, and it has been designed for technologies which are even more constrained in terms of communication capabilities than those which we deal with in 6LoWPAN or 6Lo, such as, for example, LP1 technologies. So here we are interested in using SHIC header compression in 6LoWPAN environments, since it is possible with SHIC to compress an IPv6 UDP header down to a size of, for example, just 1 byte, again, in the best case with global addresses. And the technique is that static context is used here, which exploits a priori knowledge of the header field values of the packets to be sent or received. Then, if we include also the application layer, we may want to compress the whole set of IPv6 UDP and CoAP headers. And well, there is no 6LoWPAN header compression defined for CoAP. So then we can consider 2 cases for a CoAP header as an example. If we assume a header without CoAP options, then with 6LoWPAN, the resulting size of IPv6 UDP CoAP header would be 11 bytes in total. If we consider the options in a CoAP header, such as those in table 6 of RFC 8824, the resulting size would be 23 bytes. However, by using SHIC, which by the way has also some specification to compress CoAP headers with SHIC, then it is possible to compress the whole set of IPv6 UDP and CoAP header down to a size of, for example, just 2 bytes. Then, with this decrease in the amount of bytes to be transmitted or received, it is possible to achieve significant improvements. For example, in terms of the theoretical battery lifetime, when a node is running on a battery and transmitting packets, for example, periodically over 15.4. As you will see later, it is possible to achieve a theoretical improvement by a factor which might be even greater than 2, even if we include a 3rd byte as a SHIC dispatch. And however, a disclaimer here is that actual improvement in practice will be lower depending on various parameters and features such as the device hardware, and in particular, the sleep current consumption. Also MAC layer settings, application layer settings, including the payload size, network topology, and so on. So just to give a few more details on this, here this figure shows on the vertical axis, which is the maximum theoretical battery lifetime improvement factor that can be achieved for the cases considered as a function of the co-op payload size, which is the horizontal axis. Here we assume short MAC addresses, intra-PAN communication, and again, a battery-operated device which transmits packets periodically. So here you can see there are red curves and blue curves. The red ones correspond to a star topology scenario, and the blue ones correspond to a multi-hop scenario with mesh under. I will refer to route over later in the presentation. And as you can see, while the improvement decreases with co-op payload size, of course, it is still possible to achieve quite significant improvement, at least theoretically, with shorter co-op payload sizes. So, on the status of the draft, you may recall that there was initially a related document, which was a proposal to define a 6LoWPAN dispatch type to signal when SHIC header compression is used, which was presented in IETF113. And that led to creating this draft, which has a greater scope, which is intended to enable like all the details to allow transmission of SHIC compressed packets over IEEE 802.15.4 networks. The previous versions, 00 and 01, were presented in the last two IETF meetings. And here I'm presenting revision 02, which aims to incorporate the feedback from the last IETF and also from the couple of LP1 interims where related topics have been discussed. So let's go through the updates in this last revision. The first one relates with the frame format. Here you can see the format on the slide, which starts on the left with the SHIC dispatch, which signals that what comes next is a packet with a header which has been compressed by using SHIC. And the SHIC header, the compressed SHIC header, comprises two components, a rule ID, and if any, a compression residue. So in the previous version, we stated a fixed size for the rule ID of 8 bits. However, after comments in the last IETF, we have modified this, and now we say that the recommended size for the rule ID is between 1 and 16 bits. The idea is to allow the most suitable rule ID size to be decided and used for each specific environment. And also, we would like to avoid like a hard limit on which could be the network size and number of endpoint pairs that can benefit from SHIC header compression. By the way, just in case, I'm seeing my screen like full size, so I cannot see if there's anyone in the queue. So if there's anyone, just let me know. So then the next updates are in section 5.1, which focuses on IPv6 UDP header compression. So by default, what is done here is use section 10 of the base SHIC specification, which is RFC 8724, to compress IPv6 or UDP header fields. However, there's a bit of a problem with IPv6 addresses and UDP ports because SHIC is based on the LP1 architecture. And in that case, there's special terms and elements, such as the ones shown in the figure, where at the left you have constrained devices, which would adopt the role of DEB. And on the right, we have a network side infrastructure, which would adopt the role of app. So in the base SHIC specification, the DEB and app terms are used. Actually, the rules for compression and decompression are written for the IPv6 addresses and UDP ports in terms of who is DEB and who is app, and actually there is no mention of source or destination. So the point is the rule is expressed in terms of DEB and app. So in LP1, this is not a problem because a SHIC entity knows in advance whether it is DEB or app. And then as we clarify in 02, in some 15.4 scenarios, this is not a problem either. And in fact, this is actually an optimization in SHIC, in the LP1 context, because this allows a compression-decompression rule to be used in both directions. So this same optimization can also be used in some 15.4 scenarios, as is, for example, in star topology networks, where the constrained devices talk to some network-side infrastructure. However, the problem may arise in other scenarios, like two peers, two constrained devices that talk to each other within a mesh topology, because according to the definition of a DEP, if both endpoints are constrained devices, both could have the role of DEP. So here we need to address this problem. So one possible solution, which is the one that is currently in the last update of the draft, which has been discussed in LP1 interims, is that we might want to tell a node whether it is DEP or up in advance. So additional functionality is needed for that. And here, each endpoint might need to know whether it is DEP or up when talking to any other possible potential endpoint. So it means that we might need to give additional context to the nodes. And then there's a related point, which is that the basic specification also defines the terms uplink and downlink, which are in terms of dev and up, because uplink means from depth to up, downlink is the other direction. And if we follow this approach, it means that uplink and downlink would have a local meaning just specific to each pair of endpoints. So in 0.2, currently we have this approach. We remove some sort of tentative solution that we attempted in the previous version in 0.1, which was using the terms source and destination in the rules. However, this would have the issue of duplicating the number of rules, because we would need one rule for each direction. And well, we also attempted to use transmit and receive as possible replacements for uplink and downlink. However, well, that is now gone. So we are trying to stick to what is already provided in the basic specification in terms of dev and up. So I don't know if there's any comment on this.
Yeah, I just wrote in the chat that since you have to install these rules anyway, you have to establish the static context that is being used here. Can't you establish the row rules at the same time? So when you install a rule set, you install them for node A as app and node B as dev?
Yeah, so actually that's my current idea. And I understand that this corresponds to what has been suggested so far. Well, there have been like different suggestions in the LP1 interims, but this is one approach which reuses the functionality of dev and app mostly as it is. And yeah, so since the rules need to be written beforehand, then I understand that the context to know whether a node will be dev or app even for different endpoints, I think it can also be established beforehand as well. So I think that rules and deciding the roles would need to be done at the same time.
So what is the way you envision the rules to look like? So a particular node, how many rule sets will that node have, and is there any sharing between these rule sets?
Yeah, that's a good point, and actually it's considered in a slide I have next as next steps.
Okay.
Yeah, exactly. Yeah. Thank you. Yeah, so actually we are trying to be a bit generic so far in the specification, trying to capture perhaps from small networks to larger networks. So yeah, at the moment we are trying not to limit anything in this regard. And yeah, one related point is the one you just mentioned about whether rules could be shared or something like that, and even reused across different pairs of endpoints. Yeah. Okay, thank you for the comments. So then Also, another addition in 02 is regarding some text in the basic specification, which states that the app IID CDA, which means compression decompression action, cannot be used on LP1 technologies that only carry the depth identifier in the data frame. However, in 15.4, now we explain in 02 that data frames carry both a source and a destination field. Therefore, the app IID can actually be used, of course, if the IID can be reconstructed based on information available at the L2 header. So then we've also added a few details on the security considerations. So because this specification doesn't define new header compression functionality beyond the one in the basic specification, the security considerations of section 12.1 in the basic specification, which focus on header compression, apply here. And we've added also that the security considerations of section 9 of IFC 8824, which is SCHIC for CoAP header compression, also apply, because we also want to be able to use CoAP header compression here. And also we've added a requirement in 8824, which is that cryptographic integrity protection is required to protect SCHIC headers. So here we also copy the same requirement, and in fact we explain that in 15.4 networks there's also support for link layer encryption and authentication, so it's possible to support this requirement. So as possible next steps, well, it would be good to try to stabilize on the discussion about dev and app and writing the rules accordingly, perhaps beforehand, as Karsten mentioned. Then subsequent questions could be, okay, do all nodes need to store all the rules that need to be used in the network, or perhaps is it possible to reuse rule IDs across disjoint pairs of endpoints? Well, this is something to be considered. And also there might need to be something to clarify about the scope of SCHIC header compression for IPv6 UDP in these peer-to-peer 15.4 topologies, because it appears there's not much of a challenge when there is one hop between source and destination. And also when there are several hops between a source and a destination, it's quite not very challenging to perform this compression in mesh under. However, it might become more challenging in the route of a scenario. And in fact, there is some experience in the working group with a related similar topic. So perhaps we might want to approach first the one hop case and the mesh under case, and perhaps leave route over, at least for IPv6 UDP, for maybe a later specification. So, well, this is perhaps another point to discuss. And, well, other than that, since most of the content and the main goals and the structure of the document has been stable at the moment, or is getting stable, then the authors would like to ask the working group whether it could be a good moment for adoption. So any comments or questions?
Yeah, so I think this is really interesting work. Carsten Bommer again, by the way, sorry. I think you, as an author, you probably want to make one or two more rounds completing the architecture before you push this into the working group. Because as an author, you have more flexibility in doing this. So I would probably look at this at IETF 114, but that's just my personal opinion. If I were author of this, I would not ask for adoption today, but try to make sure this is complete, so the working group does the small points then.
Okay, thank you. Any other comments? Okay, so well, I'm not seeing anything else than my slides. So I guess if there are no other comments, then we can proceed to the next presentations on the native short address draft. Thank you.
Here we go. Native address, short address.
I can control from my.
Yeah, I'll give you the control. Let's see if it
Yes.
works. I haven't seen it work yet.
It worked for me yesterday, but you never know.
Okay, so you're participant in the queue, but I have to find you. I can't click on your name in the queue. I have to find you in the rest of the thing. Luigi, there we go. Pass slide control. Does it work?
Apparently.
I think so because it changed. Yeah.
Okay.
Woohoo.
So I'll give you an update on the Lee6LO native short address draft. Okay. No, there is not the
Huh?
right set.
That's not
This
the right
is
set?
This
Okay.
is for the next call.
Okay, let's do that properly then. Let me see. I think you have to exit. Can't take it away from you.
I mean, I quit.
Yeah, quit. Yeah, there you go.
I request again.
Yeah, you didn't need to put your name in it. So this is native sort update share. And there we go. Sorry about that.
That's great. That's the right deck. So that's an update since 112. We submitted 2 revisions, one in December, one before the cutoff date in March, so not that long ago. So the main changes between 0001, this is the one submitted in December, we did quite a lot of text revision. We clarified the scope, why is in scope, or we believe it's in scope of the 6LO working group, because we don't actually do really routing, but it's more on a stateless forwarding solution. I mean, but the main point is really addressing and how we build addresses, okay? We clarified the applicability of the solution. For this, thanks again to Pascal, that did help a lot in the text in order to really be clear. And it's obvious that the applicability is more in a static deployment, because as soon as you have a topology changes, you should renumber or do routing. Okay, we don't want to do routing. Renumbering is complicated. Okay, and we add the text in order to clarify the allocation function, which is basically the function that builds the addresses, and some small discussion about simplicity versus optimality. And we have a new quote or long that jumped on board. Main changes between 0102, which is the last that been submitted. Again, revised the text, added some stuff. We did some further work about the clarification on the applicability scope, and we tried to move it earlier in the document, okay, so that it's clear right away where this solution can apply, what is the use case, basically. We tried to clarify the architectural overview, the roles of the nodes, because we have a root, then we have forwarders, leaves. We try to better define the different roles and what each node is expected to do. Okay, and for the address assignment procedure, we added 2 neighbor discovery options, which I'll detail in the following slides. So the idea is to leverage on ND already available in 6LO PAN. Okay, basically we have 2 simple options. Okay, to request an address and as a reply to assign an address from the parent node. So we call it NSA request address option and NSA assign address option. Okay. this means we updated the IANA section with the right format to request this, to allocate the options. So the request is pretty simple. Is a type, and the type has to be allocated by IANA anyway. But in the request, what we put basically is the expected address lifetime. It's like, I want an address, and I want it for this expected period of time. Okay, and in the reply, what we have is basically, here is the address, here is the lifetime that I give to you, and here is the prefix length. Okay, and then there is the actual address, full format, and then the node is able actually to retrieve the prefix because it has all the information plus the NSA address. Okay, because of the peculiar format, it's very easy to extract it from the full address. Okay, details in the draft anyway. So on the next step, you will see the evaluation in the next presentation. Okay, Rock, Lee Guangpeng will give a short demo. We try to evaluate a little bit how much and where is the gain with this approach. We need to incorporate further feedback that we received actually after the latest submission. So we have Brian Carpenter, Adnan Rashid sent interesting feedback, I have to say. So all in all, we believe the core of this document is stable, but we need a revision of the document for the feedback. Okay, we expect to do it right after 113 because already we have the feedback. And at that point, we may consider adoption of a working group adoption because again, the core elements are stable. There is not that much to be updated, we think. And that's all. If there are any comments or questions, further feedback, everything is welcome. Okay, nothing in the queue.
Okay, so yeah, maybe just a clarifying question. In the draft, you state that the applicability would be for rather static environments with wired technologies. So is that, for example, PLC, or do you envision other technologies as well?
We envision other technologies, but we are still looking at them. I mean, we do some bibliographic work, and we may add a few more references in 03, but we want to make sure that we don't say nothing wrong just to add some references. So maybe it's the most honest answer I can give.
Okay, thank you. Yeah, it will be good to clarify a bit more what kind of scenarios would be in place here. Yeah.
Sure.
Thank you.
Have another question?
Rock?
Hello. To answer this question from Galas, except the PLC, and there is another physical layer technology named APL, Advanced Physical Layer, which is based on the standardization of IEEE 802.3 is also suitable for this NSA technology in the network layer, I think. Thanks.
Okay, thank you. Is just curious, is that for constrained devices? Is it like maybe more general? Which are the typical use cases?
Yeah, partly yes. There are many scenarios for the intrinsic safety requirements, which will constrain the resources of the client. In the industrial equipment domain.
Okay, thank you.
Thank you.
More questions?
Yeah, thank you.
as they further, and also from the perspective of the operators, also working how to use IP address in more scenarios. So I think it's a really good way to apply the short IP address without unnecessary routing function in the IoT. So maybe I hope the WG could consider this work. Yeah, thanks. That's all.
Okay, so I'll hand back the control.
Okay, so next is a presentation still on the same draft. However, it's a demo.
Okay, thanks. Hello, everyone. This is for the demonstration of the NSA allocation function, which is described in the draft of native short address version 2. Next page, please.
I gave you the slide control. It should be at the bottom of
Oh,
your screen.
okay. Thank you. I can't control.
Oh, let me try
Scroll
again.
down.
I don't have
Sorry.
it. I keep trying to pass you slide control. I
Yeah.
don't have it. I don't have slide control and you don't. Let's try again.
Okay, thank you.
Okay, so I'll just get it. Next
Okay.
slide. There we go.
Okay. And the specifications described in the draft states 3 points. First of all, the allocation function of the NSA can be different case by case, but all nodes under the same root must use the same one. See section 4 in the draft. And for the example algorithm for the allocation function is given in the draft. It's very simple. And today I'll show the demo implemented based on this algorithm. So the target address will be allocated by parent address plus some binary ones and plus the row bit which indicate the node is leaf or forwarder. And the third point is about to calculate the max length of the address. And the max length of the address for a node equals the length of the parent address plus the length of the ones and plus 1 bit. Next, please. Thank you. And the code is very simple. We can see in the slide only one page for the core code for the core code of implemented allocation function. And most of the parameters used by the allocation function is local variables, and only the parent address is a global context. Okay, next I'll show the output of the program. Next, please.
Again?
No. Okay. So there are two keys designed for the demo. Case 1 is to generate a topology and assign addresses for the topology, and the parameters will be set is the layers in the topology of the tree, and the second parameter is maximum children of one code, of each code. Sorry. So here we give an example of a 4-layer tree topology, and for every node have have 4 children. Because we choose the random mode, so not every node has a full amount of the children. So for the output of the program, we can see there are totally 23 nodes, and the maximum address length is 6, owned by the blue nodes, and the average length of the addresses is only 4 bits. So this will prove the efficiency of the allocation function is very high. Okay, next please. We'll go to case 2. For case 2, the program will read an arbitrary graph from a file and try to allocate the NSA addresses for the file. And there are totally 21 nodes in the input file. And after the allocation, we can see the correct NSA addresses has been successfully allocated. Okay. Next, I'll request to share my screen and to show the live demo. Do you want to? Yes. Yes. Ooh. Okay. The shared screen is okay for you?
Yes, we see it.
Okay, thank you. And we can run the program and see the parameters 4 and 4. We can fill larger numbers, but because the display problems, so we use 4 and 4 as example. And we can use random and generate the topology and evaluate the length of the addresses. And there are 16 nodes, and average address length is only 3 bits, and the maximum length is 6. And we can draw this. So we can see the maximum length is 6, and for the blue nodes. After we have this tree, and the nodes can calculate the next hop by the destination address and not rely on the separate routing table. And for case 2, we can load. Let me delete the output file first and select code space. Sorry. Oh, okay, code space. And I see product and example topology. Okay, we can see the addresses are allocated successfully, and the output file is generated. And okay, this is the input file. We can see no addresses is labeled for the nodes, but after allocation, we can see the address, the NSA address is labeled for every node here. Okay, and that's the whole demonstration here. Any questions or comments? Thank you.
Go ahead, Pascal. You had a question, Pascal?
Yes, I find it very fun. Then I can see where it can be useful in specifically hardware environments like a car. If you look at the harness of a car, where every UID, every device has a very fixed position in a kind of an electrical wiring, then I can see that this simplifies the routing inside the harness and avoids having a point-to-point, I'm sorry, a star type topology on the harness, which consumes more copper. So I really can see how this can be useful. On the other hand, I have this concern that the way it's done today implies that you're building a tree. And I would like the next generation of this document, and I see that Luigi is being occupied, and that's sad because I'm talking to him. But I would like the next generation of the draft to cover a more meshed topology, possibly 2 non-concurrent trees or something. So 2 addresses per device, so that if you have a wiring which allows 2 paths to reach the same device, it would effectively get 2 addresses, and you could send the packet to the 2 addresses to make sure that one of the packets reaches the destination. So basically, what I'm saying is, in IoT environments, we like redundancy. And you talked about safety networks, etc. Safety network condition 1 is redundant. And so please consider how you would build not 1 but 2 trees and different addresses and redundancy, and that would make it really suitable. You see the point? A tree is not enough. 1 single tree is not enough.
Thank you. But in case 2, we read a topology which is not a tree, it's a graph, and we can.
But the routing has to follow, because you don't do routing, the path of the packet along the graph is exactly my point. The path of the packets along the graph is limited because of the addressing, right? Because you have to follow the addresses. It's my understanding. You don't have a routing protocol. So if you basically want to use 2 different non-concurrent paths to the same device, you need to give it 2 addresses on 2 different topologies. Make sense? No sense? We can follow the mailing list.
Sorry, I didn't follow your question.
Okay. You have a mesh, right? You showed the mesh effectively, and you can show it back if you like. Now, the path of a packet, my understanding is that it is constrained by the address as following the bits, basically. So the path, the effective path in this mesh is a tree. And I see that as a limitation because we want redundancy. So what I encourage you to look at is something like giving 2 addresses to the device to build 2 trees which would not be congruent, so that each address can be reached even if there is a failure. Otherwise, you break somewhere in the tree, the whole subtree is disconnected.
Why the disconnection occur? Because our dedicated scenario is a stable topology.
If
maybe
if one of the nodes breaks in the tree that you showed in the address, the addressing is a tree, right? Even if you build on a mesh, the addressing is a tree. If you break a node somewhere in the tree, you need to go. You can only go through that node to reach the children, right? Because you follow the addresses. So if you break this node, you lose the subtree.
Yes.
If it dies.
Correct.
Yeah. That's my point.
When a node break, yes, we lose the.
Yes, you lose the subtree.
Yeah.
IoT and mostly the use case that you gave of safety, you require redundancy. It's a must. You have to have 2 paths. You have to have non-congruent. That's why Ripple builds DODAGs.
Correct.
So the next version of this draft, if you could show how you build 2 trees and find the 2 paths non-congruent, so probably you have 2 addresses, then that would give you redundancy. That's my suggestion for you.
Okay, so thank you for the discussions. Yeah, sorry. Yeah, we are 4 minutes already past the time. So thanks a lot for all the discussions, and let's continue discussing on the mailing list. And the session ends here, and let's hope we'll see each other in person or virtually in the next IETF.
Okay, thank you, Chair.
Thank
Thank you,
you.
Pascal.
Are we done?
Yeah, it seems
All
we're done.
over?
So thanks a lot, Michael.
Welcome.
Yeah, thank you, Mike. Thank you, Michael.
Have a nice lunch, everyone.
See you in Philadelphia,
See you.
I hope.
How to get away from
Thank you. Bye-bye.
Thanks. Bye.
Thank you.